Astronomers have made an intriguing observation concerning Neptune. The majority of the clouds that traditionally adorn its recognizable blue atmosphere appear to have vanished, rendering the distant planet nearly devoid of these cloud formations. In contrast to Earth's serene blue sky, Neptune's atmosphere is in constant flux and teeming with activity, featuring some of the swiftest winds in our solar system, reaching speeds of up to 2,000 kilometers per hour or 1,200 miles per hour. These turbulent conditions stir up clouds composed of methane and other gases, creating an ongoing spectacle, akin to a dance that is barely perceptible from Earth. However, the recent development that all the clouds on Neptune have seemingly vanished is a surprising twist, dramatically altering the planet's appearance. Scientists have unraveled the cause of this transformation, the 11-year solar cycle, a phenomenon that continues to baffle us. So how did astronomers uncover this explanation for the disappearance of Neptune's clouds? How does the Sun, situated 4.4 billion kilometers away, exert such a significant influence on Neptune's atmosphere? Lastly, what evidence substantiates this hypothesis? Neptune remains the least explored planet in our solar system, with Voyager 2 being the sole spacecraft to have ever ventured there. During its historic flyby of Neptune in 1989, Voyager 2 unveiled an intriguing and enigmatic atmosphere on the ice giant. The spacecraft observed the turbulent atmosphere with robust winds and captivating cloud formations. Moreover, Neptune's atmosphere is stratified into multiple layers, with the uppermost layer being the troposphere, where visible clouds take shape. The most noteworthy discovery was the Great Dark Spot, a colossal storm system akin to Jupiter's Great Red Spot, and Voyager 2 determined that Neptune's Great Dark Spot was comparable in size to our entire planet. Nevertheless, when the Hubble Space Telescope turned its gaze towards Neptune in the 1990s, the storm had mysteriously vanished, marking the initial indication that elements in Neptune's atmosphere undergo substantial transformations. Voyager 2's investigations also unveiled the chemical composition of Neptune's atmosphere, identifying hydrogen, helium, and methane as the primary constituents of its cloud structures. The methane in Neptune's upper atmosphere absorbs red sunlight, leaving only blue light to be reflected, thus giving the planet its characteristic blue hue. Voyager 2 conducted a comprehensive study of Neptune over a 5-month period, providing a wealth of data on the ice giant. Subsequently, no spacecraft has ventured to Neptune due to the formidable challenges, exorbitant costs, and vast distances involved. Nonetheless, astronomers have not abandoned their quest to understand this distant world. Since the Voyager 2 mission, Neptune has been periodically observed using potent space telescopes such as the Hubble Space Telescope, allowing astronomers to monitor changes in its cloud patterns and identify new features. Additionally, ground-based observatories equipped with adaptive optics have supplied high-resolution images of Neptune's atmosphere, revealing finer details of its cloud formations. Despite this ongoing observation, Neptune's cloud cover is anything but constant. It continues to evolve, with the clouds nearly disappearing over time. To meticulously track this vanishing act, researchers analyzed the variation in cloud cover over the past 3 decades, scrutinizing infrared data collected by the Hubble Space Telescope, the Keck Observatory, and the Lick Observatory between 1994 and 2022. Their findings are indeed surprising. Neptune, located 4.4 billion kilometers from the Sun, receives a mere 0.1% of the sunlight that our planet enjoys. One might naturally assume that the Sun's impact on Neptune's atmosphere would be negligible given this extreme distance. However, when scientists scrutinized images of Neptune captured by various telescopes over the past 29 years, they discerned a striking correlation between seasonal changes in Neptune's cloud cover and the solar cycle. This implies that, despite its tremendous distance from the Sun, Neptune remains influenced by our star's fluctuations. Presented here are images captured by the Keck Observatory and the Hubble Space Telescope from 2002 to 2020. specifically employed in the current study. Notably, cloud activity decreased, particularly in the mid-latitudes, starting in 2020. For instance, since 2019, scientists have only observed a single patch of wispy white clouds drifting around Neptune's southern pole. Even after 4 years, these clouds have not returned to their previous levels, rendering Neptune nearly cloud-free for the first time in 3 decades. The question that naturally arises is, how does the Sun play a role in this phenomenon? To grasp this connection, it is essential to understand the solar cycle. Similar to humans experiencing moments of high energy and times of extreme fatigue, the Sun undergoes fluctuations in its energy output. It alternates between periods of heightened activity characterized by numerous sunspots, energetic outbursts, and quieter phases, constituting what we call the solar cycle, a reflection of the Sun's changing behavior. Typically spanning around 11 years, the solar cycle mirrors the Sun's dynamic nature. During periods of solar turbulence, when the Sun is at its most active, the solar system experiences heightened ultraviolet radiation. Solar cycles are a natural aspect of the Sun's behavior, influencing space weather and, consequently, Earth's magnetosphere and communication systems. In a recent study, scientists meticulously examined the past 2.5 solar activity cycles, marked by maxima in 2002 and 2015 and minima in 1996, 2007, and 2020, in order to investigate their connection with Neptune's cloud formations. This investigation uncovered a significant pattern. The appearance of clouds on Neptune typically commences approximately 2 years after the onset of intense UV radiation. Additionally, a conspicuous link was established between Neptune's cloud cover and its albedo, a measure of the sunlight reflected by a planet. Cloud cover and albedo reached their peaks in 2002, declined in 2007, surged again to a peak in 2015, and subsequently subsided. These timing patterns corresponded with the 2 most recent solar activity maxima in 2001 and 2015, thus establishing a clear correlation between these phenomena. One potential explanation for this phenomenon revolves around the hypothesis that the Sun's intense UV radiation triggers a complex photochemical reaction leading to the formation of Neptune's clouds. However, this relationship is intricate. For example, increased UV sunlight could enhance the photolysis of methane gas, resulting in the production of hydrocarbons and associated hazes. Conversely, a surge in UV radiation might darken aerosols and hazes, thereby reducing Neptune's overall brightness. Nevertheless, observations have consistently shown a positive correlation between solar activity, cloud cover, and the planet's brightness. This suggests that Neptune's internal processes may also contribute to this behavior, implying that the Sun may not be the sole driving factor. Ongoing observations and newly acquired data from the James Webb Space Telescope align with these findings. Nevertheless, sustained observations of Neptune are necessary to arrive at a definitive conclusion. What are your thoughts on the mysterious disappearance of clouds on Neptune and their surprising connection to the solar cycle? Do you believe the Sun's influence on a distant planet like Neptune is more significant than previously thought? Engage with us by leaving a comment, subscribing to our channel, and clicking the notification bell for regular updates. Keep watching, stay inspired, and get ready for more exciting discoveries. See you in our next episode.